Okay, I think it's recording already. So yeah. So hi everyone. My name is Edison Su. Yeah.
And my name is Siap Ho. Yeah.
Yeah, and we're from Harvard University, Malaysia. We're both year one students studying actuarial science. So today we are doing like a tutorial video on solving simultaneous equations. So we're gonna run through like some examples and give you some basic steps on how to solve simultaneous equations. So I think let's begin. I'm just gonna share my screen. Okay, Kaho, can you see my screen?
Can, no problem.
Okay, great. So, okay, let's start solving simultaneous equations. So the objective is to be able to solve simultaneous equations by two methods, which is method of elimination and substitution. So let's just start with the first method, which is the method of elimination. Right, so actually, essentially the method of elimination is to sort of cancel out one variable in the equation so that we can solve one variable at a time. So basically simultaneous equations is like you're given two equations with two different variables and you have to solve to find the value of each variables lah. Right. So as you can see here on my screen, we have this example to solve the simultaneous equations through the method of elimination. So we have two equations, 4x plus 3y equals to 1 and 2x minus 3y equals to 14. So what I want to do here is we want to eliminate one term, either x or either y. So if you can see in this example, it is easier for us to eliminate the y terms. And how we do that is we just add equation 1 and equation 2 together. So yeah, as you can see here, this will result in 6x equals to 15, which you can solve for x to give x a value of 2.5. So after that, we substitute x equals 2.5 into equation 1, and we can solve to find y. So from here, the solution for x will be 2.5, and the solution for y will be -3. So a good practice, I would say, to have when doing simultaneous equations is that you can always check whether your answers are correct. So how to check? You substitute the x value and the y value that you have gotten, and you sub it back into the original two equations. If the original equation stands, meaning let's say you sub 4x as 2.5 plus 3y, you sub it as -3, and if the equation gives you 1, that's how you know that both your variables, you have found the correct answer for that lah. So yeah, it's pretty simple. So we'll go to the second method now, which is the method of substitution. So the method of substitution is a bit different from the method of elimination in the sense where for the method of substitution, we are going to rearrange one of the equations to make one variable the subject of the equation. So what do I mean by that? Okay, let's go and look at the example question. We have y equals 3x minus 10 and x plus y equals to -2. So here you can see that for equation 1, y is already the subject of the equation. So it's easy enough. We can substitute y. We can substitute equation 1 into equation 2. So equation 2 will become x plus y will be substituted as 3x minus 10. And then the whole thing will be equal to -2. So as you can see here, we can just do a normal solving, normal algebra, and we will get x equals to 2. So once we get x equals to 2, we substitute it back into equation 1, and we will get y equals to -4. So therefore, the answer for this question is x equals 2, y equals -4. And as I said previously, it's good to check whether your answers are correct or not. And you do that by substituting the answers for the variables that you've got into the original equations and see if the answers stand. And yeah, right now we're going to run through some basic examples, and I'm going to pass the time back to Kaho to do that.
Okay. So for the first example, solve the simultaneous equation by elimination. And we know that the first equation is 8x plus 3y equals to 7. And the second equation is 3x plus 5y equals to -9. And the first step we do is we take the first equation times 5 and the second equation times 3. And the first equation will become 40x plus 15y equals to 35. And we will denote it as the third equation. And for the second equation will become 9x plus 15y equals to -27. We will denote it as the fourth equation. And second, Secondly, we will use the third equation minus the fourth equation, and we will get 31x equals to 62, because 15y minus 15y is equals to 0. So we will get x equals to 2, and we will sub it into the first equation, and we will get y equals to negative 3. So therefore, x is equals to, and y is equals to negative 3. So to make sure it is correct, and it must be consistent with second equation. So we sub x equals 2 and y equals negative 3 into the second equation, and we will get negative 9, which is correct. And next, we will look at the third example. The cost of the taxi journey is made of two parts. There is a fixed charge of X dollar and then an extra charge of Y dollar per kilometer. The total cost for a 5-kilometer journey is 14.60, and the total cost for the 12 km journey is $23.84. Find the total cost of a 24-kilometer journey. Okay, firstly, we know X is a fixed charge, which is not affected by the distance, and Y is charged per kilometer. So we form the first equation first. Firstly, x plus 5y equals to 14.6 is the first equation. Due to the 5-kilometer journey is cost 14.60. And second equation is x plus 12y equals to 23.84. For the 24-kilometer journey is x plus 24y. So we need to find x and y first. X plus 5y is equals to 14.6, and then x plus 12y is equals to 23.84. So we let the second equation minus the first equation, we will get 7y equals to 9.24, and we will get y equals to 1.32, and we will sub it into the first equation, and we will get x equals to 8. So for the 24-kilometer journey, the cost is 8 plus 24 times 1.32, which is $39.68. Next, we will look at the fifth example. The straight line AX plus BY equals to 9 passes through the point 12, 5, and -6, -7. Find the value of A and B. Sometimes the coordinate geometry question requires some knowledge of simultaneous equation. For example, the first point, 12 and 5, which is x equals 12 and y equals 5. We form the equation 12a plus 5b equals to 9. We denote it as the first equation. And the point -6 and -7, which is x equals to -6 and y equals to -7, we form equation 2, which is -6a minus 7b equals to 9. Okay, so we use 2 times the second equation, we will get -12a minus 14b equals to 18, which is the third, denote it as a third equation, and we will use the first equation plus the third equation. We will get -9b equals to 27, because of the -12a plus +12a is equals to 0. So we will get b equals to -3, and we will sub it into 1. The first equation, sub it into first equation, and we will get a equals to 2. Therefore, a is equals to 2 and b is equals to -3. So next, we will look at some few examples for the solving simultaneous equation by using substitution method. So for the first question, we know that the first equation is x plus 2y equals to 4, and the second equation is x equals to 3y minus 11. So we can straight away sub the second equation into the first equation, which is 3y minus 11 plus 2y equals to 4. And we will get that y is equals to 3, and we sub it into 2 in order to find x. So x is equals to 3 times 3 minus 11, which is -2. Therefore, y is equals to 3 and x is equals to -2. Then we'll look at the second example for this. The second example is y equals to 2x minus 7 is the first equation. And the second equation is y equals to x minus 3. So for this question, it's quite easy to do. Why? Because we got 2y as the subject. So we can equate the y together, which is 2x minus 7 equal x minus 3. And then we will get x equals to 4 and sub it into either one the first equation or the second equation. For me, I will sub it into the equation 2, and I will get y is equals to 1. Therefore, x is equals to 4 and y is equals to 1. And next, we'll look at the third example. Find the coordinate of the point where the lines y equals to x plus 2 and 3x plus 2y equals to 14 intersect. From coordinate geometry, we know that if we want to find the point that they intersect, and we need to make the simultaneous equation for both of them. So we know that the first equation, we denote the first equation as y equals to x plus 2, and the second equation as 3x plus 2y equals to 14. And then we know that by substitution, we can sub the y equals to x plus 2 into the second equation. So we'll get 3x plus 2 times x plus 2 equals to 14. And we'll get x equals to 2. And then we will sub the x equals to 2 into the first equation, which is y equals to 2 plus 2, which is 4. So therefore, x is equals to 2 and y is equals to 4. And after this few example, I will pass it to Edison to show you some question of the harder question. Yeah.
Okay, thank you, Kaho. So
Yes.
let me reshare my screen. What we're going to do now is that we're going to solve some questions on the spot. So let me just pull up and share my screen again. Okay, you can see my screen, right, Kaho?
Yeah, can. Good.
Okay, so we're going to run through 1 or 2 questions on the spot. I'm going to do it on the spot, and you can sort of see how we do it, right? So let's just look at the first example. 1,000 tickets were sold. Okay, adult tickets cost $8.50 and children's tickets cost $4.50, and a total of $7,300 was collected. So how many tickets of each kind were sold? Right. So right now we have 2 variables, and I'm gonna denote them as X would be the number of adult tickets, right? And Y would be the number of children tickets. Actually, no apostrophe, yeah. Children tickets. Okay, so looking at this question, we are supposed to formulate 2 equations in X and Y to solve for X and Y, right? It's simple as that, because they're asking how many tickets of each kind were sold. So right now from the question, I can see, if you can see here, 1,000 tickets were sold, right? So from that, we know that the number of X plus Y will give 1,000, because the total number of adult tickets and total number of children tickets sold is 1,000. So that's our equation 1. Next, we can formulate a second equation, which is from the total amount collected. So as you can see here, the total amount collected is $7,300, and we can get that by multiplying the price for a single adult ticket with the number of adult tickets, and add that with the price of a single children's ticket multiplied by the number of children tickets sold. So that will be our equation 2. So for this example, I'm going to solve it using the method of substitution. Right. Okay. So right now I'm going to formulate a third equation. I'm going to use equation 1, and I'm going to make X the subject of the equation.
Sorry, Edison.
Yeah.
I think you write the 4.50 is y, not x. I think is.
Oh yeah. Oh yeah. Oops, that was a mistake. Thanks, Kaho.
Yeah, it's okay. It's okay. No problem. No problem.
Yeah. So yeah. So it's 4.5y, because we want the number of change tickets. Right. Okay. So where was I? Okay. From equation 1, we will formulate equation 3. I'll rearrange to make y the subject of the equation. Personally, I prefer to use y and convert y as the subject of the equation. It's just a personal preference. You can use x, works either ways. So what I do now is that I'll sub equation 3 into equation 2. Let me just scroll down a bit. Sub equation 3 to equation 2. Then we'll get $8.50 x plus $4.50 multiplied by 1,000 minus x equals 7,300. Okay, then this is just basic algebra. 4x equals to 2,800, if my math serves me right. Yeah, x equals to 700. Right, so now we know that the value of x, which is the number of adult tickets sold, is 700. So we can sub this back into sub x equals 700 into equation 3. And we will get the value of y as 700. So therefore, the solution for this question is x equals to 700.
Sorry,
Y
Edison, I think
equals,
it's minus 700.
my apologies.
No problem, no problem. Yeah, yeah. Just
Yes, thank you for that. Okay, so yeah. 1000 minus 700 equals 300. So we know for this question, the solution is x equals to 700 and y equals to 300. So as we mentioned above, I'm going to just move this to the bottom a bit. We have to check if our answers are correct. Actually, I'll just do it up here. So we do a check. We sub x back into the first equation, 700 plus y, which is 300. Does it equals to 1000? Yes, it does. And for the second equation, we sub x equals to 700 and y equals to 300. What does it give? Let me check in my calculator. Yeah, it gives 7,300. So yeah, so always remember to good practice to have is to check your answers during examination so that you have you can double check if your answer is correct or not. Right. So we're going to move to the second example question here. So it says Mrs. B invested $30,000, part at 5% and part at 8%. Right. So the total interest of the investment was $2,100. So how much did she invest at each rate? So right now, what's the first step? The first step is to solve. So basically we have to solve for x and y, right? So right now we have to denote our x and y. So x is number of money, actually amount of money invested at 5%. Y will be amount of money invested at 8%. Also, I forgot to mention this at the first question, but yeah, so if you're watching this and you would like to try it out by yourself first, feel free to pause the video and just do the question first, and then you can play the video whenever you're ready to see if you have gotten the correct answer lah. But anyways, let's just continue. So we have our x and our y. We have our x and y. So right now we have to formulate two equations from the question. So we know that Mrs. B invested 30,000. So the amount of money invested at 5% and the amount of money invested 8%, when you add them together, it has to be equal to 30,000, right? So that is our first equation. X plus y equals to 30,000. Equation 1. Our next equation, Mrs. B invested part of the money at 5%, part at 8%. So the total interest on the investment earned was like $2,100. So we have our second equation now. 0.05x plus 0.08y equals to 2,100. Right. And I'm gonna make an equation 3 from this so it's easier for us to solve. Because I don't like solving it in decimal places, right? I like solving it in whole numbers. So it becomes 5x plus 8y equals to 210,000 if I'm not mistaken. Because basically you just times 100 here and times 100 here to get rid of the decimal points. So basically this is just equation 3. Right. So since we solved the previous question in methods of substitution, my personal method, I prefer substitution because actually in most cases it's much easier. But just for this tutorial video, I'm gonna do this question, solve this question by methods of elimination. So how do we go about this? Right. So right now we're supposed to, method of elimination is supposed to eliminate one variable, right? So I'm gonna take equation 1 and convert equation 1, I'll multiply both sides. So equation 1 is like that, right? I'll multiply both sides by 5. So it becomes 5x plus 5y equals to 150,000. So I get my equation 4. It might get a little complicated for those of you who are new at it, but just bear with me. Can pause the video and just digest it first. But yeah, so we have our equation 4. Right now, if I want to use methods of elimination to solve, I want to eliminate one variable, which you can see here. Both equation 3 and equation 4 has a 5x. So I will use that, I will eliminate 5x. So what I do is I use equation 3 to minus equation 4. From that, I will get 3y equals to 60,000. Therefore, solving for that, y will be equals to 20,000. Okay. Y will be equals to 20,000. Then I can sub this back into the original equation, equation 1. So y equals to equation 1. Then you get x plus 20,000 equals to 30,000. So therefore, x would be 10,000. And you will get the final answer. Therefore, x will be 10,000, y will be $20,000. Okay, always remember to check. So for equation 1, 10,000 plus 20,000, obviously it equals to 30,000. And from equation 2, 0.05x plus 0.08y would be equals to 2,100. Should be correct. So there you have it. That's how you actually solve simultaneous equations using methods of elimination. So I guess that's about it. That's all we have for today. So I hope you actually found this video helpful, and yeah, and you have learned something new, or you have had a good revision on simultaneous equations. I think that's all we have for today. So yeah, like I said before, hope you enjoyed the video, and I think we'll see you soon. Thank you for now.